Hi everyone. So today we're gonna talk about summary of introduction to operations research. What we're gonna learn about is to be familiar with the origin of operation research, when it started, how it started, what are the common applications of operations research in real world, and to know what is the scope of operations research, where we can apply it, when can we apply it, and to understand the definition of deterministic operations research. So basically, operations research started during World War II with the goal of utilizing the resources of the US military and British military army in a best way to fulfill the objectives of those armies. So basically, that was the main motivation behind the invention of OR. We have a set of limited resources. Think about it like ships. We have a limited number of ships, limited number of trucks, limited number of soldiers, limited number of personnel generally. How can we utilize those resources in a way that will help fulfilling the goals of those armies during the World War II? So sometimes those goals are conflicting, so OR also helps in allocating these resources in a way that could result in fulfilling uh, those conflicting goals by using the limited resources efficiently. And how did they do it? They actually applied the scientific method. And we will see later what does a scientific method means. So in a nutshell, operations research basically means applying or conducting research on operations, and originally it was military operations. Okay, so that's how it started. How did it shift to be applied in all other fields in the industry? The motivation was basically the Industrial Revolution. So when the Industrial Revolution started, it has led to rapid growth of organizations because the production was faster, demand started to be faster. Sometimes we have some departments and some companies started to grow larger and larger, and therefore they started to have their own goals that sometimes resulted in having goals that conflicts with the goals of the company itself. Therefore, it started like the problem started to become more complex, and some goals started to be conflicted with the company's goals due to the complexity of problems. Also, the complexity of problems resulted in problems that are hard to solve using just the traditional methods. So that was the main motivation of the shift of using OR in the industry. Now, what is the common thing between the industry with its different fields like business management, manufacturing, investments? All other fields have common things with the military operations. Basically, all of them have certain objectives. Sometimes they might be conflicting objectives. And they have limited resources companies do not have accessibility to unlimited resources. They have limited number of employees. They have limited amount of money. They have limited amount of time. They can, for example, fulfill orders. So it's the same thing. We have certain objectives, limited resources. We want to utilize these resources efficiently to solve complex problems and to fulfill certain objectives. Therefore, again, in the industry, we use the scientific method, which is the word research, to manage operations. Therefore, sometimes it's called or is called the management science. Now, we said before, we apply the scientific method to manage operations. Well, what does scientific method means basically? And the scientific method basically starts by defining a problem. And to define a problem, you have to determine the objectives you want to fulfill by the end of your research. And then after you determine the objectives, you start gathering data to have just an insight about the problem, or sometimes you need some more information to be able to tackle the problem, or to understand the factors that govern the problem of interest. After you determine the objectives, gather data, you determine key factors. Now you have a quantitative ways to measure your factors, which is from the data that you gathered, and you determine the objectives. This is usually the job of engineers and scientists. After doing all that, you can formulate a solid problem statement, or you can say, I defined the problem statement of the OR project. After that, we need to do some abstraction, simplification of reality, and set of assumptions. The goal of all of that is to convert the problem statement from plain English statement into a mathematical model that anyone who understands math will be able to understand the objective of the problem, will be able to understand the constraints of the problem. Constraints means the limited resources, basically. After we formulate the mathematical model, we will use optimization algorithms. Basically, it's a standard procedures for solving problems. So after that, after using the optimization algorithms, we generate a solution for the model. After we generate the solution of the model, we test the validity of the model. Does the model actually reflect the real life problem that we want to tackle? Is the solution applicable? Did the problem change after implementing the solution? Because sometimes, let's say you're planning for production, and you planned for certain demand that happened in the past by the data, based on the data that you collected. Did the demand change? If the demand changed, you might need to actually update your model to reflect the change that happened in real life. But if nothing changed, you can just go ahead. If the model makes sense, if the solution is applicable, and the problem didn't change, we can go ahead and implement the solution. Does the solution that we want to implement make sense? What does that mean? Sometimes, due to weak formulation of the model, the model will produce results that actually doesn't make sense. For example, we want to produce like 225.5 units in this month to maximize the profit. But we all know that the number of units should be integer. So you might do some like adjustments to the final solution so that it makes sense to actually implement it. Again, you will ask, after these adjustments, is it applicable? If it's applicable, then that's great. We can go ahead. Sometimes, like you don't want to work over time, but the solution resulted in a solution, or the solver resulted in a solution that needs working for over time. So, and you did not put that as a constraint in your model, then the solution won't be applicable. Therefore, you need to again either reformulate the problem, or you can adjust the final solution so that you don't work over time. Again, and you ask the following question, over time, after like a few months, for example, doing your operation research project, you'll ask, did the problem aspects change? Is there any new factors that are affecting our problem? If there is none, then you can use the same model. If there is a change, then we need to go back, do reformulation, solve the model, and the cycle keeps going on and on. Which actually, this is the reality of operations. They just keep going, keep changing. They are in a dynamic state all the time. So this is the steps of OR study. OR has impacted the industry significantly, and these are some common examples that took place during the 90s. For example, IBM saved $20 million and $250 million less inventory due to the integration of national network of spare part inventories to improve service support. Taco Bell optimized their schedule to provide desired customer services at minimum cost. There are many other examples, but these are some examples I picked from the textbook. Finally, we need to define what is deterministic operation research. Now we know what is operations research. Finally, deterministic, we can know it from this taxonomy. Operations research model consists of stochastic and deterministic. Stochastic means probabilistic, but deterministic basically means that data that we gather, we assume or we know that they are certain. They don't change. For example, you collected the data of demand in the past and you calculated the average. You assume that the demand will stay at average level all the time. And then deterministic models have three types: integer, continuous, mixed integer. Integer, basically numbers can take only integer values. Continuous can take any value, or its domain is the real numbers. And mixed integer, basically the variables of the problem can be integers and real numbers. Finally, continuous can be linear, nonlinear models. We will talk about that in more details in the future. To conclude, we said OR started during World War II, and the reason was we want to utilize limited resources to fulfill a set of objectives. And then we extended the application extended to include a variety of fields due to the Industrial Revolution, which created a lot of complex problems in which they needed to fulfill a set of objectives by using efficiently a set of limited resources. And the computer revolution and extensive efforts paved the way for operations research rapid growth. Because of the complexity of these problems, most of the time solving them by hand only is not feasible. Therefore, the computer revolution actually helped a lot in improving or extending the applications of operations research. Operation research, basically we said it's applying the scientific method to manage operations, and it helped many companies to save millions of dollars. And finally, we said in this course we are interested in deterministic models, which means models that use certain data. And that's it for today.